Welcome, Algebra 2. Let's take a look at Chapter 5, Section 2, using properties of rational exponents to simplify expressions, and using properties of radicals to simplify and write radicals in simplest form. Chapter 5, Section 2, combining radical expressions. What we're doing is looking for like terms. For instance, if we go back to what we already know how to do, combining like terms when we have x's means that we look for the same variable and the same exponent. So 3x squared minus 1x squared, those are like terms. 3 minus 1 would give me 2x squared. Then we have x's here, we have x's here, so positive 2x and positive 4x, 2 plus 4 make 6x. We can't combine it any further because they are not like terms. Well, we saw how to do this with imaginary numbers too. When we have a complex number minus another complex number, the first thing we did is we distributed our negative, or whatever number might be in front, we would multiply through using our distributive property. So rewriting it without the parentheses. 4 plus 2i minus 3, two negatives make a positive, and then minus 2i, two negatives make a positive. And I look for like terms. Real number with real number, 4 plus 3, those are like terms. And imaginary with imaginary, 2i plus 2i would be 4i. We don't do any more with it because 7 is real, 4i is imaginary. They're not like terms. If we can do that with x's and with imaginary numbers, we can certainly do it with radical expressions also. You have 3 radical 5 plus 2 radical 5. Well, we keep the radical. It's almost like saying 3x plus 2x. And we simply need to add the numbers that are outside the radical. 3 plus 2 would give us 5 radical 5. Let's check it on our calculators. So if I start with the problem that I had, I have to be very careful about closing my parentheses. So 3 square root is over on the left-hand side. You go second x squared. We've been doing those for a while now. There's our 3 radical 5, closing my parenthesis, plus 2 square root of 5, closing my parenthesis. It starts me with the parenthesis. I just need to remember to close it. Should be 11.18. If I put my answer in, 5 radical 5, that means 5 times the square root of 5. I get that same decimal. I know my answer is correct. As long as the type of radical is the same, you can combine like radicals. A like radical would be when it's both a square root, or in our case, both a cube root. 2 cube root of 7 minus 1 cube root of 7 would give us 1 cube root of 7. But multiplying 1 times anything doesn't matter. We would leave it as the cube root of 7 for our final answer. How about you try? Not only does it work with radicals, but it works with the same exponent too. Hit pause, come back when you're ready. All right, welcome back. So we have 4 times 5 to the 1/4 power plus 2 times 5 to the 1/4 power. So the 5 to the 1/4 powers. This is almost like having 4x plus 2x. We would have 6 times 5 to the 1/4 power. And we could leave our answer right there. That'd be fine. We could put this in a calculator, get a decimal if we really wanted to. But exact answers are usually preferred over decimal estimates. Or we could also use the fact that we know 1 is the power, 4 is the root. So we could say 6 fourth root of 5 to the first. I'm not going to write 5 to the first. 5 to the first is 5. Anything to the first power is itself. All right, go ahead and pause for a minute. You try square root of 12 plus square root of 3. Welcome back. Let's take a look. We don't have like radicals. If you were thinking of square root of 12 plus square root of 3 is square root of 15, sorry, you can't add different radicals. Radical 12, not the same as radical 3. But we have learned how to rewrite square root of 12 in simplest radical form. You think of two things that multiply to 12 using your perfect squares. 4, 9, 16, 25. Hey, 4. 4 times something is 12. 4 times what? 4 times 3. So now we can simplify. The square root of 4 is equal to, well, square root of 4 is 2. Don't know the square root of 3 plus the square root of 3. And then we add the numbers that are out front. There is an invisible 1 here, if that helps you. 2 plus 1 would be 3, radical 3. Put the problem in your calculator, put your answer in the calculator, you should get the same decimal. If you do, you know you did it right. If you don't, you made a mistake. You and your group take about 7 minutes, 7 minutes, to work on simplifying radicals part 2. Hit pause, come back in about 7 minutes. Welcome back. The other piece today is taking a look at how to simplify variable expressions that have an x in them. So let's take a look at how to do this when we have different radicals. They're clearly different, and we're multiplying. We're not adding anymore. We don't have to worry about like terms. We need to figure out a way to break this down or to combine it. I think about square root of negative 2x. There are no perfect squares in there. I think about square root of 10x to the 5th. Not really any perfect squares in there. Perfect squares would be things like 4, 9, 16, 25, 36, right? Perfect squares. The ones in your multiplication chart that are in the diagonal. 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. So what can I do? Well, I can put everything together in a single radical. Because I'm multiplying, I'm allowed to multiply the numbers underneath the radical. I can take the negative 2x times the 10x to the 5th. Putting everything under one radical. But then probably what I'm going to do is I'm going to put the numbers together and I'm going to put the variables together. So if I put the negative 2 and the 10 next to each other, or if I go ahead and I multiply those, that might be a good idea too. We'll take a look at a couple different ways to do this. I'm going to start multiplying. Negative 2 times 10 is negative 20. And then x times x to the 5th would be x to the 6th power, because you have 1x here, you have 5 more x's there. You multiply them together, you got 6. Is 20 a perfect square? 4, 9, 16, 25? No. So I start thinking, how can I break that 20 down? Using a perfect square, like 4, 9, 16, 25. Well, I'm pretty sure 4 times something is 20. And if you don't know, you can always use your calculator. You can always go 20 divided by whatever to find the other number. But 20 is 4 times 5. So we have a negative 4 times 5 times, well, let's see how many x's we have. You got 6x's, right? What's the square root of 4? 2. But better yet, what's the square root of negative 4? Negative 4. Anytime you take the square root of a negative, you get an I. So the square root of negative 4 is 2i. Do we know the square root of 5? Please say no. Okay, no, good. Then it stays under the square root. Then we have x to the 6th. If you go back to what we did the other day, x to the 6th means you have 6 x's that are multiplied together. We have a pair, we have a pair, we have a pair. We have 3 pairs of x's. My answer, 2i x to the 3rd radical 5. That's one way to do it. We're going to see another way we can do this too later on, but your first technique might be multiplying things together and then breaking it apart. If you think back to a couple days ago, here's another way that we can do this. We could try to put things together and break them down. Negative 2 times x times 10 times x to the 5th. Negative 2 times, well, what multiplies to 10? 2 and 5. Times x times, x to the 5th. 1, 2, 3, 4, 5, for a total of 6 x's. Here's my x to the 3rd. I have 3 pairs. Those pairs go out. Here's my pair of 2's, but it still leaves me that negative. The negative is the I. We have a pair of 2's, that becomes 2i x cubed. Sometimes you break it apart, sometimes you multiply them together. You've got choices. Let's try this one. Square root of negative 8x squared times square root of negative 2x to the 6th. I'll try the first technique of multiplying things together. Negative 8 times negative 2 is 16. X squared times x to the 6th. Well, you have 2 x's here, 6 x's here. That gives you 8 x's that are multiplied together. And then we think, do we know the square root of 16? Square root of 16, yes, it's 4. And you have 8 x's. There they are, 8 of them. How many pairs can you make? Well, there's 2 in a pair. 1, 2, 3, 4 pairs. So that gives you x to the 4th power. Hey, maybe this is you. When you finally finish a math problem and you realize it isn't even one of the answer choices. That might be you during like ACT time, right? It happens to everyone. Or maybe this is you, me in math class. Well, we did this with square roots. Let's try with cube roots now. The cube root of 4x to the 3rd times the cube root of 4y to the 5th. Cube roots are a little tricky. We're not looking for a pair, we're looking for 3 of a kind. So it might be our best bet with a cube root to break things down as far as we can. For instance, 4. Well, that's 2 times 2. X to the 3rd, x times x times x. 4. Well, that's 2 times 2. And then y to the 5th would be 1, 2, 3, 4, 5 y's multiplied together. If I put my numbers together, then my x's, then my y's, I can see what will be a perfect cube. So we have 2 2's here, 2 2's here, got our ballerina outfits on, we got our tutus on. We have 3 x's, and we have 5 y's. Now we look not for 2, because that would be a square root. Now we want 3 of a kind. For every pair, that makes 1 2 that goes outside. Every 3 2's inside make 1 that goes outside. The cube root of 8 is 2. For every 3 x's I have, I get a single x that goes outside. And for every 3 y's I have, I get 1 y that goes outside. Nothing else creates a triple, so we're left with the cube root of, are there any numbers left? Yes, there's a 2. Are there any x's left? No. Are there any y's left? Yes, I have y times y, which is y squared. Final answer, 2xy times the cube root of 2y squared. How about you pause, you try, you're doing square roots, you want pairs. Put everything together and look for pairs. Hit pause, I'll be here when you get back. All right, welcome back. -3 times x times x times x is x cubed. Times 9 is 3 times 3. X squared is x times x. Times 2 times y. I'm going to put all the numbers together, all the x's next and the y's last. Then I can look for pairs. I've got -3, which is, if you think about it, -3 means -1 times 3. The negative is going to give you an I. The negative square root, right? Can't take the square root of a negative number. Gives you an I. Got a couple 3's over here. Got a 2 down here. So I got all the numbers I put together. Now we'll put all the x's together. We have 3 x's here, 2 x's here, 3 x's to the left, 2 x's to the right, make 5 x's. Got our number, x, 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 x. That leaves me with the y. Let's look for things that make pairs. Why not 3 of a kind? Because it's not a cube root. These are square roots. Square roots, we want 2 of a kind. Well, I've got my negative, gives me the I. I got a pair of 3's, that'll go outside. I've got 2 pairs of x's that go out. Does anything else pair up? No. Then whatever's left I didn't use, didn't pair up, they get to stay home. 3 times 2 is 6, and we have 1 x and 1 y left over. 3ix squared times the square root of 6xy. If you need to see more examples, be sure you go to my website, Chapter 5, Section 2. There are always help videos on every single topic we've done all year long. All right? These are good videos. It's not me. It's somebody with much better hair than me. Chapter 5, Section 2 in groups, simplifying variable expressions. Hope you guys have a nice day. I'll see you next time.